Okay, so welcome back guys to this Python 101 programming series where we're going to be talking about one of the most basic but also one of the most important aspects in programming, which are variables. So first things you want to do is open up your IDE, so whether it's VS Code or PyCharm, or hey, if you want to install something else, go for it. I've got PyCharm, so what I'm going to do is new and pick a place where you want to store your program or your programs. So I've got a Python 101 file, and I'm just going to call this folder variables. That's where we're going to store it. So in these episodes or whatever videos, we're not going to be using any packages or anything like that, or at least not for now, not for the beginners stuff. So if you want to create a virtual environment, you can, but you don't really need to. I'm going to, because PyCharm just does it for me quite happily. So yep, I'm going to click create. So yeah, so what we're going to do is create a new Python file. Oh, my microphone's died. Rip to all the headphone users. Right, that was fun. Now, what I'm going to do is create a main file, and yeah, if you're on VS or VS Code, you'll probably be done by now, but in PyCharm we've got to do just one more little thing. So, as you can see, the run, debug and other buttons are greyed out at the moment, and that's because it doesn't actually know, or it's not been told where to run or what to run. So we need to press add configuration, press the plus button, go down to Python, and script path, we need to open that up, and we need to specify whereabouts our script is, so it's main.py. Apply, OK, and now we're done, so we can start writing our code. So first things first, what I'm going to do is simply write out a print statement. Not that, I'm going to try to write out print statement, and I'm just going to put hello. There we go. And I'm going to say I'm 18 because it will make me feel better. So if we save that and run, we'll know that it outputs what we've written, which is what we thought it would. But you see, programs in general, you know, they're not going to be dedicated, well, okay, they might be, but you know, they're not going to be dedicated for a specific, you know, hello, you know, we're not going to give out a program to everyone who's called Robin who they're 18 years old. Pardon me. Instead, no, we want to ask them what their name is, what their age is, so that we can personalize this program, so we can create it, so we can make it dynamic and we can change it. And we can do that by using variables. So what we can do is we can type, or at least the things we'll want to change, or the things we might want to modify, are the name and the age. So we need to create two variables, one called name. I'm going to set it equal to Rob. I'm going to set another variable, and we're going to say we're going to set it equal to 18. Now, really, all the variable is, it's just a container which stores some form or some type of data. That's all it is. And we use that variable, or at least we get that piece of data by calling this variable name. Okay? So if we now say print name, and put it in brackets, we can we'll now see that it outputs what is inside this variable name. And one thing that, let's say, one thing you might notice if you've come in from a different language, or if you venture off into other languages, you'll notice that certain things Python does differently, and one of those things is the fact that in C++ or C# or something, we don't need to write out what type of data we're going to put in. So in C# or C++, you might need to write int or string, because we're specifying what this container is supposed to be containing, what type of data it's supposed to be containing. In Python, we just say, here's a name, here's some data, and do stuff. And Python's okay with that because the way it works is we write out our variable name, in this case name, we use the equal sign to assign something, so we're assigning this piece of data to this bit on the left, and we just type out what we're wanting to put in. So in this case, wanting a string with the string of Rob. In this case, we're just putting 18, so we're using an integer. And this is how Python works. It says, okay, have we got speech marks? Yes, we do. So it's probably going to be a string. You know, have we got a number? Yes, we do. There's no speech marks around it, so it's an integer. That's kind of how Python works. It's how oh god, my brain went. It's called dynamic typing. And Python is an example of a dynamically typed language. Statically typed languages would be something like C# and C++, where you would have to write out int or string or whatever. But anyway, enough of that. So what we can now do is, because we've got our name variable, we've got our age variable, we can now change our print message to output what is inside these variables. So we do that by putting a speech mark there, comma, name, comma, and comma there, like so, and let's just make it a bit more pretty. There we go. So, oh, that needs to be changed to age. So what this is doing is it's outputting hello my name is, then it's finding whatever is inside name, and then outputting and I'm, which should really be an apostrophe, and it's then finding what is inside age, outputting age, and then years old. And that's kind of how it works. So the output is going to be exactly the same, which it is, happily. Oh, and there's a space there where there shouldn't be. Print it now. There we go, now it looks pretty. And that's how it works. So the output's exactly the same, but now we've changed it. So up here we can say something else like Bob or whatever. And instead of going through our print messages and stuff like that, we can change anything in our variables, and it's reflected down here, because all this is doing is calling what is ever inside this variable, or the data inside that variable. Now, that's fine, that's nice, but there's still a fundamental problem with this, and that is those are hard-coded. We want something where we can provide an input or give an input, and then the program outputs whatever the input was. So we want to say, okay, you know, here's our program, you can type your name, type your age, and it will output whatever you've written. So what we need for that then is we need to store the input that the user provides. So we can go back to our name equals, and then we write input, and we can say enter your name. Let's enter your name. Oh, and let's make it pretty. There we go. And age is equal to input. Enter your age. So what this is now doing is, instead of hard coding things, we're now asking the user to provide their own answer, and whatever that answer is going to be stored in our name and our age variable. And as you can see, we don't need to change anything there, which is nice. We can just run. We enter our name, so Rob, and your age, say 18, because it'll make me feel happy. And there we go. So although the output hasn't changed, we've made our program so much more user-friendly, but also so much better, because now we're giving, allowing input. We're allowing the user to give their own information, their own pieces of data. And this is what great about variables, and they're just containers. They don't care where the data comes from. If it's a piece of data and it's the right sort of data it needs, then it's happy. and we provide our data by using input or by allocating it by hard coding, so typing something blah. So that's that. Now let's create another variable, and let's create a robot variable, and let's give it a name of Baxter. And let's create another robot variable and another one, and these are going to be OpenDog. This one's going to be Mars Rover. And what you'll see in PyCharm and probably most of the others is, or at least PyCharm, you've got this little kind of highlight, and this just means that what this is actually doing is it's where we're renaming, or we're deleting what's inside robot at the moment, in this case Baxter, and we're giving it a new piece of data, OpenDog, but then we're deleting OpenDog and providing Mars Rover. So if we print that, because it will be nice to show, what it's actually going to print is Mars Rover, because because it's the same variable name, but we're giving it another piece of data. It's not adding to it, it's just replacing it. So what we need is we need to change our variable names. So robot, robot1, robot2 is fine. And you know, that's okay. It's created three strings in this case, which is fine, but it's a bit messy and there's much better ways of doing it. And one of these ways is really simple. What we do is we can get rid of that, put a comma, and print our name there, or paste it rather, and cut and paste. So now we've got one variable name called robot. We can get rid of those, and it's got data. The data it's got is Mars Rover, OpenDog, and Baxter. If we now print this, print robot, we'll see that indeed it's got the data of Baxter, OpenDog, and Mars Rover. But what's going on here? You know, we've got a little bracket and we've got a quotation mark. We don't want that. Now, the problem we've got is that although you know, these individually are strings, and we can see this by getting rid of that and using print type robot. So if we use this type, it's going to output the type of whatever this is. So in this case, it's going to output a string. Class str is string. So it's outputting. It's letting us know that the type of this variable is a string. But as soon as we add things to it, we add OpenDog and Mars Rover, and we type print type is robot, we can actually see that it's changed. It's not a string anymore, it's a tuple. So, you know, that's all well and good, but it's a bit annoying that we've still got these. And that's because a tuple, it's basically, it's just, it's lots of strings, essentially. It's a list of strings. Now, I don't want to get too much into this because there is a list in Python, and there's a tuple in Python, and they're essentially the same thing. The difference we'll get onto in just a second because it's an interesting little thing. So, yeah, so this robot is now being changed to a tuple. So, and what we're doing is we're outputting the tuple. We're outputting the data of the tuple. But what happens if we want to get rid of this bracket and this quotation mark? What happens if we want to get Mars Rover just as it was when it was a string? Well, there's a few ways of doing that. So the first and probably easiest way to kind of handpick which ones we want is by typing print robot, and using square brackets we can type in a value from 0, 1 or 2. Now indexes in Python and most other programming languages except for MATLAB start at 0, so this isn't index 1. This isn't index 1, it's index 0. That's index 1, that's index 2. So although there's three things, or we may perceive that as being three things, actually it's starting at 0, so this is going to be 2. So 3, it will throw an error, 2, it will output Mars rover. But anyway, so if we say robot 1, we're now going to see OpenDog, but without the quotation marks. And again, we can print all of these and do 0, 1, and 2. And what this is going to do is print Baxter, OpenDog, and Mars rover, just as they were just as they were on their own. The difference, obviously, is that now we've got them stored in one variable, on one list. Now, what we're actually doing here is we're saying, okay, we want to go to the robot variable, and we want data inside the robot variable, but we want a specific piece of that data. We want an element of that data. We want the first element, in this case, kind of the 0th element. We want the next element in that list, and we want the next element in that list. And this is how we output the actual piece of data, and not just output the whole thing as what it is. So now what we can do is we can say, okay, let's say we want to store what is inside the first element of that robot. So let's call it A. And what we can do is we can say print type A. And we can prove that these on their own are still strings, it's just they're inside a tuple. So if we press run, we can say that, we're looking at the first element in that list, or the first element in the tuple, which is Baxter, and this itself is a string, which is exactly what we had before. So this is the difference. It's the difference of 3 string variables versus 1 tuple with 3 strings inside. Okay, so that's fine, that's good. But let's say we've got 1,000 elements in our tuple, or 1,000 elements in our list, or just lots of pieces of data. We don't want to be, sitting down, typing 0, 1, 2, 3, and 4, and so on. What we can do instead is we can loop through this. Essentially, we can automate this process. That's basically what the loop will do. It will automate the 0, the 1, the 2. So how do we do that? Well, there's 2 types of loops in Python, as far as I'm aware. There's the for loop and the while loop. Now, we'll get onto the while loop in probably a future video, but for now, what we could do is type for robot in robots. Actually, what I'm going to do is change this to robots to signify that there's more than one inside, and colon. And one thing to really to mention, basically, that's really important in Python is indenting. So you must make sure that all of your code is indented like this. This is obviously okay, but when you are using things like anything essentially that has a colon after it, you need to make sure that it's indented, because if your code is like this, if you write some more code there, then what essentially will happen is that this will be outside the for loop. So let's actually show kind of how it would work. So if you write print and let's just type hello. So what will happen is this will print hello 3 times, because there are 3 robots in our robots tuple. So if you print that, it's going to print out hello 3 times. So, and then if I kind of de-indent that, it's going to come up with an error saying that an indent is actually expected, and if we run it, it's going to come up with an error. Yeah, so make sure that your code is indented whenever there is a colon after it. Righty, so as we were back to where we were going. So we've got our robots list, okay, and what we're doing for kind of each iteration through this list, we are going to create a robot variable, and it's going to be a string, and the string of that robot is we're going to output it. So it's probably best just showing you how it will work. So print robot, and that's it. That's all it is. So if you print that now, we've got Baxter open dog Mars rover, Baxter open dog Mars rover. So we've eliminated, one line of code in this case, but what this will do is now go through the entire list, or the entire tuple, and output all of the elements inside the tuple. And as you can see, without the brackets and the quotation marks and stuff, which is awesome. And all this is doing, we can actually see. So previously, we got the element of one of the robots in our robots tuple, and we got the type of it, and it was a string. So if we do the same here, we can say print. Actually, we can do it. We can do it here. We could say print type robot, like so, and press OK. And as you can see, we've created 3 strings. And it's exactly the same as what we had before with print robot. A equals robot 0, robot 1, robot 2. So yeah, so this is a tuple, contains multiple pieces of data, in this case strings, and this is how we access all of the elements in that list, and we can do stuff with it, which is cool. So let's say we want to combine all the stuff we've done at the moment and add some more robots to this tuple. Well, we can try it, but I don't think it's going to work. So let's give it a go. We can say robots is equal to input add a robot, and then we can say print robots. Well, that worked. That's annoying, because what it's actually done... Right, yes, I think I know what it's done. So, which is a little bit annoying. So, if we type print type robots, and then print type robots here, so it's the same thing. We need to add something. We can actually see that it was a tuple, and now it's been redefined as a string, which is a bit annoying. But what you'll find out is tuples, you can't add anything to them, but at the same time you can't really you can't delete things either, which renders it a bit of a problem, because what happens if we want to add more things to it? So what happens if we write, for example, robots 0 is equal to, let's think of another robot, Atron, let's say, and then we're going to write for loop again, robot in robots, and print robot. Now what's it saying here? Tuples don't support item assignment, which means we're going to get a big error and say, no, doesn't like this. And the issue is, as we know, we can't add things to it dynamically, which means that, you know, as soon as we run the program, this is what you get. So we can't add anything, we can't delete anything, but also we can't really replace anything either. So we can't say, okay, just go to robot 0 and just type atron, change it, which is a little bit irritating. And this is where the difference comes between tuples and lists. So what we've been doing at the moment is we've had tuples, sorry, this is a tuple. So what we can do instead is we can change it so that actually it's a list, and we can say Baxter, and actually I'll keep it as speech marks just to keep it consistent. Open dog, and what was the other one we said? Mars rover. Okay, so the only thing really that's changed in this entire program is we've added these square brackets. That's all we've changed. The commas are the same, data's the same, everything is exactly the same. The difference is the square brackets. But what does this actually mean for our variable? What type are we now dealing with? Well, print type robots, we are dealing with a list, which is really helpful, really helpful, because now what we can do is we've got loads and loads of different things we can do to our list. So have a look at all of these and, you know, play around with them, see all the stuff you can come up with. But the best part about lists is that they can be changed whilst your program is running, meaning that what we can do is we can say robots dot append, no, that's the wrong one, robots dot append, and yeah, let's say, go away, let's say input, add a new robot. And now what we can do is say for robot in robots print robot. So, well, actually what I'll do is, damn it, there we go. Yeah, I'll copy this so we can see kind of the before and after. So we've got Mars open dog, Baxter, sorry, Mars rover, Baxter open dog Mars rover, add a new robot, atron, and now we've got a new element, new robot added to our list, which is awesome and what we really wanted. So what we can do now, oh, actually one of the really cool things is what we tried to do before was robots. We tried to change a specific element, specific piece of data in our robots tuple as it was before. So robots 0 is equal to, what should we say now? Let's say mtran, that's a good robot. And we're going to use our for loop again. Press run, add a new robot, and going to add Superbot. Superbot's a good robot as well. Actually, no, let's add Pepper. Pepper's nice. So now what we've got is, where are we starting? Okay, so the original robots were Baxter, OpenDog, and Mars Rover. Now we've added a new robot, which is Baxter, OpenDog, Mars Rover, and Pepper. And now we've changed, because we're changing it here, we're changing the first element to mtran, but it's also keeping the Pepperbot in there. So what we've done is we've assigned a list, we've created a list of robots, and this is definitely a list now, what we're dealing with. we have looped through the elements in our list, and we've outputted each element in our list. We've then appended a new robot by we've appended appended a new element in the list with the data whatever we have written, because it's using input. We've then printed out the new, improved and bigger list. We've changed one of the elements in the list. We've changed the first element, because it's index 0, to mtran, and we've outputted it all again, and as you can see, original, add the new one, we've added it, and now we've changed one of them as well. So this is why lists are really cool. They're awesome because they are completely dynamic. You can add elements, change elements, delete elements, use so much with lists, and they're going to be massively important in a lot of programs that we're going to write. And yeah, just have a look at great thing about things like IDEs like PyCharm, VS Code and VS is that we can just press dot and we can see all the different types of things we can try. We can, so what's pop, what's clear, what's count. We can have a look at all of these cool things and we can say, okay, let's have a play and let's remove an element, let's reverse the list. What will that do? So it's really cool. So have a look at all of those and yeah, have a play. But that's pretty much the first episode now. It's a half-hour episode, so I'm sorry it's been quite long. But I think we've covered quite a lot. We've gone from printing something that is completely hard-coded and can't be changed, to adding some variables to allow us to change our hard-coded message. We've then used we've used input to allow the users to provide their own pieces of data. We've looked at tuples and outputted the entire list of tuples, or the entire kind of all of the elements in the tuple. We've looked at why tuples, or at least we've looked at the issue with tuples, which is that they can't add, remove, delete, or change elements already assigned. And we've started to look at lists where that restriction is taken away. So yeah, I think it's been really good. Now, one thing just quickly to point out, and we're going to use a comment again, so Control / for PyCharm, Control K and C for VS Code and VS. Additionally, if you want to multi-line comment, which just means that you don't need to press the hashtag all the time, what you can do is press the apostrophe 3 times, and this is now a multi-line comment. But we'll delete that. So yeah, so you may be thinking, you want a bit more distinction between the tuple and the list. Adding these square brackets is okay, but you want to really make sure that you get the difference. You can just see straight away that's a tuple, that's a list. Well, the thing you can do is have normal brackets, and we can say print type and robots, play, and as you can see, it is a tuple now. So depends on which one you prefer. You can have it you can distinguish them like this by using these types of brackets versus these types, or you can have it just so there aren't any brackets at all. Either way, it's with or without brackets, they're a tuple. It's just if you want a bit more distinction to say, okay, that's definitely it, then you can do that if you want. It's entirely up to you. But yeah, that's it for this episode now, for definite. And yeah, cool. Have a play with things. try to add and remove and replace elements in your lists by using for loops. Also, if you want to have a bit of a extra challenge, look at while loops and implement the same program using a while loop. That should be interesting. So thank you very much, and have a good day.